Okay, here is the setup for practice 15A, acids and bases in solution. So the first thing you're going to want to do is get the dissociation equation going. HCl dissociates into H plus and Cl minus. This is a 1 times 10 to the minus 2 solution of HCl, which means you're going to get exactly the same amount of H plus in solution times 10 to the minus 2 and Cl minus, even though we don't really care about that. So what's our H plus? 1 times 10 to the minus 2 molar. You're going to solve for OH using this guy, where you know that Kw is always 1 times 10 to the minus 14th. Okay, so let's set this up. OH minus is equal to Kw divided by H plus. You know that Kw is 1 times 10 to the minus 14th. You know that H plus is 1 times 10 to the minus 2 because that's what you got up here. And let's bang it into our calculator. So we're going to say 1 times 10 to the negative 14th. Sorry about that. 1 times 10 to the negative 14th divided by 1 times 10 to the negative 2. Here's our answer, 1 times 10 to the negative 12th molar. Okay? Super easy. Let's do number 2. So this time we're starting with a base, sodium hydroxide, and you know that it's going to dissociate into 1 sodium and 1 hydroxide. So if this is 1 times 10 to the minus 3rd molar, that means this is 1 times 10 to the minus 3rd, and so is this. So what's our OH minus? 1 times 10 to the minus 3rd molar. Let's solve for H plus, and this time we're going to use this version where you know Kw, which is always 1 times 10 to the minus 14th, and you just found OH minus. So equal to Kw divided by OH minus, which is 1 times 10 to the minus 14th, divided by 1 times 10 to the minus 3rd, which you just found. So let's bang it into our calculator. 1 times 10 to the minus 14th divided by 1 times 10 to the negative 3rd, 1 times 10 to the minus 11th. That's our OH minus. I'm sorry, our H plus concentration. Okay? All right, let's keep it rolling. Now you got the hang of it, right? Super easy. Here is H2SO4. You know that because there's 2 H's, you get this, 2H plus, and SO4, 2 minus. So because there's 2 H's, if this is a 1 times 10 to the minus 2 molar solution of H2SO4, you get 1 times 10 to the minus 2 molar SO4, but twice as many H pluses, 2 times 10 to the minus 2 molar. So what's our H plus? 2 times 10 to the minus 2 molar. Let's solve for OH minus. We've already done it. We know it's Kw divided by H plus, which you just found. So this is 1 times 10 to the minus 14th divided by 2 times 10 to the minus 2 molar. Let's pound it into our calculator. 1 times 10 to the minus 14th divided by 2 times 10 to the minus 2. 5 times 10 to the minus 13. That's our OH minus. Okay, one more. You're getting the hang of this, right? This takes you 5 minutes once you got this all figured out. We've got calcium hydroxide, which we know is going to dissociate into 1 calcium and 2 hydroxides. So this is a 2 times 10 to the minus 3rd molar solution of calcium hydroxide. So you're going to get exactly the same amount of calcium, but you have 2 hydroxides. That means you're going to get twice as many as our original solution, 4 times 10 to the minus 3rd molar. So what's our hydroxide? 4 times 10 to the minus 3rd molar. Let's get our H plus. This is equal to Kw over OH minus. You know that Kw is always 1 times 10 to the minus 14th. And you just found OH minus, which is 4 times 10 to the minus 3rd. So here's what it looks like in the calculator. 1 times 10 to the minus 14th divided by 4 times 10 to the minus 3rd. Pow! 2.5 times 10 to the minus 12th molar. 12th? Yeah. Okay? Easy peasy. All right. See you guys later.